Okay. Now we're going to configure IPv6. So this time we may pick up different router, maybe 4311 ISR router is bit another model. So 3 router we picked up. And then we're going to connect R1 to R2, R2 to R3. And we can do configure IPv6 subnet. So I put 2001:1:/64. This is one of the subnet. And from this subnet, we have IP address. This is 2, and this side it will be 1. Right, 2001:1:1, 2001:2:2. Then another subnet will be 2. This one, IPv6 address will be 2:2, 2:3. So from the subnet, we have this IPv6 address. Okay. After that, see, after router 3, we do not have anything. But if you'd like to advertise some another subnet, we need to add another router. But instead of adding another router, we can configure loopback address. Loopback address. What is a loopback address? Loopback address or loopback subnet. Loopback is a kind of virtual IP, virtual interface, but we can configure. Let's say this is I put loopback 1. Loopback 1. In here, I can put another subnet 2001:3:/64. We can assign loopback and loopback interface. The advantage is testing purposes. We can add separate subnet. So in here we have a separate subnet. Also, let's say we want to advertise another subnet. We can say loopback 2 2001:4:/64 space EUI 64. So we can see how UI64 will function. So in here, we can assign IP address 3:3. See, this one manually we can assign IP address, and other one just to check it out how UI64 functions, we just put UI64. So with the loopback address is we can use for testing purposes. Let's say we can add another subnet and see how it works. In our networking environment, many different scenarios we configuring loopback address for testing purposes. Okay. Now we're going to configure IPv6 address. I'll go to my router, go to CLI. But now here enable config T, hostname will be R1. Interface gig 0/0/0. See, this interface is written in this way. It's kind of like a module, slot, and interface. So we have to follow this one and say IPv6 address 2001:1:1/64 and say no sharp. In this way, we configure the IPv6 address. It's very similar. It just you need to put instead of IP, put IPv6 and put the IPv6 hexadecimal number address. Okay, then after that, I'll move to router 2, CLI. So we'll say no here, enable config T, host name will be R2. Then interface gig 0/0/0, IPv6 address 2001:1:1:2/64. Say no sharp. Interface gig 0/0/1, IPv6 address 2001:2:2/64. Say no sharp. Then we go to router 3. So router 3 will say, would you like to enter the initial configuration? Say we said no. Then enable config T, hostname will be R3. Then interface gig 0/0/0, IPv6 address will be 2001:2:3/64. Say no sharp. And then, so this is we configured normally. Then after that, we configure loopback. How to configure loopback address? Say interface loopback 1. It will create loopback address, and loopback address is always up. And then IPv6 address. What was the address? (2001:3:3) 2001:3:3/64. So IPv6 address 2001:3:3/64. And say this one you don't need to say no shard because it's already up. Then interface loopback 2, for example, that address. But this one we do not assign IP address in this way. It's a subnet was 2001:4, isn't it? Just double checking. 2001:4:/64. Yes, correct. Space. After that, say UI64. Now, difference between this one and the other one. Other one we put separate IP address, but in here we didn't put IP address. Instead, we're saying UI64 and hit enter. Once you hit enter, automatically it will create new IPv6 address. Right? Once you do that, and say show IPv6 interface brief. With this command, you can see say gig 000, it has link local address. So link local address automatically will be generated and it will be always there. Based on the port MAC address, it will generate because IPv6 there is no broadcasting. So for all internal communications, it needs this link local address. All for local communications. And IPv6 we can have more than one address in one interface. Not IPv4 anything you configure, it replaces the old one. But IPv6 you can have more than one addresses. So now we have link local and public. And if you look at loopback 1, it also has a link local, and also this one we configured manually. But look at loopback 2. This is link local, but look at that. After 2001:4::, and this part generated from port MAC address. And you can see it came from that, is similar to that link local address. From the port MAC address, we have this one. Okay, that now in here, if I want to ping, I'll go to my router 1 and I want to ping. So ping 2001:1::2. I can ping. This one is this IP address, connected IP 2001:1::2. I can ping that one because we're in same subnet, right? But if you try to ping different subnet, let's say 2001:3:3, it will not work because we do not have any routing. Okay, that. So we configuring that one now, yeah. So let's say defense subnet is not pinging, right? After that, we say config T, and then first thing when you enable IPv6, first thing we need to say IPv6 unicast routing. That is the first command. Okay. With this one, you enable IPv6. After that, we configured in here, let's say, because we have many subnet, we can do configure OSPF. Okay. So how to configure OSPF? We say IPv6 router OSPF 1. So this one is a process. And then we have to put router ID. Router ID, I put same IPv4 format 1.1.1.1. After that, I'll exit from here and then interface, we'll take the interface gig 0/0/0 and say IPv6 OSPF1 area 0. In this way, we enable IPv6. So each of the interface, IPv6 OSPF1, one is a process and area 0. And that's it. That's how you configure IPv6. Same way, router 2 and router 3, we can configure. And each of the interface, we need to configure IPv6 OSPF1 area 0.
Giving my type thing unrecognized post or address.
So again,
When I try to ping from router 1 to router 2, I keep getting a unrecognized post or address.
like that, I ping from here in this way, ping 2001:1:2. Is it like that? From R1 to R2? Show IPv6 interface brief. So at first you check whether your all IP address configurations is correct or not. You can do show run or show IPv6 interface brief. In this way you can configure. You can check. Okay now? Oh, okay. Yeah, okay. After that, let's say we'll go to router 2, enable config T, IPv6 unicast routing. That's the first command. Then IPv6 router OSPF1, one is a process. Then router ID 2.2.2.2, and then exit from there. Say interface gig 0/0/0 IPv6 OSPF1 area 0. So one is a process, area is 0. After that, interface gig 001 command will be same, IPv6 OSPF1 area 0. So that's my router 2 configuration. Okay. After that, I'll move to router 3, config T, and then first thing, IPv6 unicast routing, then IPv6 router OSPF 1, router ID 3.3.3.3, exit from there. Then we need to check the interface. We have gig 000 and loopback 1, loopback 2. So all these three interface we need to enable IPv6 OSPF. So interface gig 0/0/0, IPv6 router, no, IPv6 OSPF 1 area 0. Then interface loopback 1, IPv6 OSPF 1 area 0, interface loopback 2, IPv6 OSPF 1 area 0. So in this way, you can enable each interface, you enable IPv6. Once you configure all the way, OSPF routing protocol should be working, and you'll be able to ping each other all the way. Okay with that? Yep. Once you configure, after that, we'll be able to see all these interface informations, protocol informations, database informations, routing informations, right? All kinds of informations you'll be able to see. So conceptually, IPv4, IPv6, they are very similar, but only things the IPv6 address is a bit long address. Okay with that? Now, if I want to check show IPv6 interface brief, right? This one we have looked at already. We get multiple address. If I say show IPv6 interface gig 000, okay, gig 0/0/0. In here, I can see gig 00 is up, line protocol is up, IPv6 enable, link local address is this one, global unicast address is this one, and this is the subnet. And you can see all these things is clearly written in IPv6. You can see all the interface up, and what is the link local address, what is the public address, what is the subnet, everything you can see. Now, every interface, we have this multicast address. All the interface, they join to this multicast address, because in this way they communicate with other routers, other device, etc. And MTU size, ICMP protocol, NDZ, neighbor discovered protocol, right? All this protocol we have in here. Maximum transmission unit, like from this interface, it can transmit maximum 1500 bytes of data. Okay. Now, now let's say this is IPv6 address. We say show IPv6 interface we have looked at. Now show IPv6 route. We can check the routing. So we have see the routing to that particular subnet. 2001:1:/64, and then under that 110 and 2. This is the 110 is the administrative distance and 2 is the cost. So this is OSPF. So basically, you can see all the local and connected options over there. But if I go to my router one, say enable show IPv6 route, you can see here we have connected subnet local IP OSPF 2:3:3:4:. So that's where I have the routing. So that means anything, if I want to ping, even let's say this is one of the IP address which is generated by UI64. If I want to ping that one, it should be working. See, I can ping anything. 2000:3::, that one should be able to ping. Right? So it's communicating. It's working. testing purposes. Let's say if we have loopback, we can test something after the router 3. Otherwise, we have to put another router and connect and then configure all IP address and everything. But instead of that, I can now test that after that I can communicate. So that's why testing purposes we using loopback address. So yeah, all the other commands show IPv6 OSPF neighbor, show IPv6 OSPF database. See on the database, you'll be able to see the 3 router 1, 2, 3, all informations basically. Show IPv6 protocol. We can see that information as well. Connected OSPF1, all this info we can see. Okay, that. So you can see that IPv6 pretty similar to IPv4, but only things the address is a bit different. Long address but major areas maybe the addresses, but majority of the stuffs they are actually similar, not very different.